Tech Talks education. Let us continue with the detection of cations using ammonia solution. So we have had a summary of the observations when a few drops of the reagent ammonia solution is added, drop-wise until in excess. So here we have the observations when we have added a few drops, and then in excess of the ammonia solution or that of the reagent. This is what we observe. So we have also looked at reaction equations in this case. For each of these reactions here, when we have added just a few drops. So here with calcium ion, we have got calcium hydroxide but solution, not a precipitate. So since it is not a precipitate, we have it as aqueous. We said that the ammonium hydroxide or the ammonia solution, since it is a weak alkali, will not be able to provide much hydroxide ions. So the little hydroxide ions that it provides will not be enough to form a precipitate, but we shall be able to get a solution but of the same compound, calcium hydroxide. Remember that calcium ion with sodium hydroxide, which is a strong alkali, it forms a white precipitate because the sodium hydroxide solution, being a strong alkali, ionizes fully and not partially and produces a lot of hydroxide ions which combines with the calcium ion and form much calcium hydroxide, which is formed as a white precipitate. Don't forget that. So magnesium ion, zinc ion, aluminum ion, lead 2 ion, copper 2 ion, iron 2 ion, and iron 3 ion. All these cations here forms precipitates of different colors, as we have already seen. White precipitate, a white precipitate, a white precipitate, a white precipitate, a pale blue precipitate, a green precipitate, a brown precipitate, when we have added just a few drops of the reagent ammonia solution. And then we are now going to look at some of these cations here. When they form precipitates on the addition of a few drops of the solution of ammonia, then in excess drops of the ammonia solution, some of them undergoes an additional reaction, and then they make us a different observation, as we have seen. And in this case, we have zinc ion giving us that. We have got copper 2 ion giving us that. These two cations here. So with zinc ion, we get a white precipitate soluble in excess ammonia solution to form a colorless solution. Even here, copper 2 ion gives us a pale blue precipitate soluble in excess ammonia solution to form a deep blue solution. That means that there is some extra reaction that they undergo in this case. So let us see the reactions that they undergo using the equations here. However, these other cations here, they form precipitates that do not undergo any other reaction in excess ammonia solution. So let us try to do away with them. In this case, I'm going to remove calcium ion with its reaction equation. I'm going to remove magnesium ion. I'm going to remove aluminum ion. I'm going to remove lead 2 ion. I'm also going to remove iron 2 ion and then iron 3 ion, because for them the excess ammonia solution do not have any effect on their precipitates formed. So let us see the next reaction that takes place here. Now in this case, let me use a different ink color. I'm going to use black for excess reactions. So this one is on the addition of a few drops. Then in excess, with the zinc ion, since the zinc hydroxide has been formed, when we add, or after adding a few drops of the ammonia solution, then in excess, the white precipitate of zinc hydroxide, we say that it is soluble in excess to form a colorless solution. So the zinc hydroxide, which has been formed as a white precipitate, will now react with the excess ammonia solution or aqueous ammonia. They are the same. Ammonia solution is aqueous ammonia. It is also what we call ammonium hydroxide solution. So it reacts, or they react to form a complex ion, which is having this formula here. So let me bracket this and I put 2 plus here. And then we also have hydroxide ion liberated. So this one is called tetraamine zinc ion. I've not said zinc 2 ion. It is tetraamine zinc ion. It is a complex ion which is found in this colorless solution here as a result of the extra reaction between the white precipitate zinc hydroxide which has been formed here and then excess ammonia solution. Let us balance this equation. I have 4 of these. This is tetraamine, 4 of these. And then we come to the hydroxide ions here. There are 2. Here we have only 1. So we multiply this one by 2. Let us check if the equation is balanced. 1 zinc atom. Here also 1 zinc atom. 2 oxygen atoms. Here we also have 2. Hydrogen atoms. Here we have 2. Plus 12 is 14. This is 4 times 3 is 12 plus this 2 is 14. Then the number of charges. Here the net charge is 0. I'm not seeing any positive or negative charge because this one is just an addition sign. So here we have 2 positive charges and 2 negative charges. So they cancel and we get 0. So our equation is balanced. So this complex ion here is called tetraamine zinc ion and it is found in this colorless solution here. Let us come to copper 2 ion, and this test we say that is a confirmatory test. That's why you can see I put a star here. It is a confirmatory test for zinc ion. Then this one is also a confirmatory test for copper 2 ion. So we get a pale blue precipitate, then in excess ammonia solution. This the pale blue precipitate, which is copper 2 hydroxide, will have to combine with the excess ammonia solution, and then we are able to get this with 4 here, then we put this one here. This is a solution and there's a 2 plus here. This is what we call tetraamine copper 2 ion. And then just like zinc ion in this case, which is also a divalent cation, we shall also balance in the very same way. We shall have 2 hydroxide ions also formed. So this one is aqueous. And this is the equation for the reaction, and this one is our deep blue solution. So do not forget that with the zinc ion and copper 2 ion, they form precipitates that dissolve in excess ammonia solution to form solutions in this case. For zinc ion it will be a colorless solution, and then for copper 2 ion it will be a deep blue solution, which you should not forget in this case. So I want us to be able to remember all these observations here with ammonia solution as per these 8 cations here, how each of them in this case tends to respond, the observations made in or on the addition of a few drops and also in excess of the reagent, and then the equations for the reaction when you have added just a few drops and then in excess for these 2 here. And I was very clear that calcium ion does not form any precipitate because in this case the calcium ion gets hydroxide ions from ammonium hydroxide, which is the ammonia solution, but it is not sufficient to form an intense calcium hydroxide. So we get just a little hydroxide ion that combines with the calcium ion and form a solution of calcium hydroxide, not a precipitate. So you don't have to forget that, and it is just because the ammonia solution is a weak alkali which ionizes partially, as we have seen from here. So it produces a low concentration of the hydroxide ion just because of the backward process in this reversible process here. So this is what we have with the detection of cations. So in our next session, we are now going to see other minor reagents. We are going to look at some other minor reagents that we can use to just confirm some of these cations here, because we have already seen the two major reagents of ammonia solution and then sodium hydroxide solution, and the order is always sodium hydroxide solution first, ammonia solution follows. And then as you can see from here, even when we have used sodium hydroxide solution and then ammonia solution, aluminum ion and lead ion still have not yet been, we have not yet in any way identified any, because using sodium hydroxide solution, they give us the same observation. Even using ammonia solution still, they give us the same observation. That is, they form a white precipitate insoluble in excess, meaning that we must get some other minor reagent that we can use to distinguish between these two here. So we don't have to forget that, and we shall look at that in our next session. TEP Talks Education, thank you for